right, so for the first part, all right, we're looking at parallelograms. When we have parallelograms, we're using that formula, area equals base times height. So down here, there's a few problems. Again, I'm going to do a couple with you, and then you can do the rest. Now, most of the directions on these pages do say find the perimeter and the area. We've already talked about perimeter in an earlier section. Again, perimeter is the distance around a figure. If you want to still find perimeter, you're more than welcome to. However, for your assignment, I'm just saying that you need to do the area. You don't have to really worry about. You don't have to worry about perimeter. So again, on here, don't really have to worry about perimeter. I'm just wanting to focus on using these area formulas to find the area of each one of these shaded figures. Number one, you have a parallelogram. Now, they labeled a couple different parts. For a parallelogram, you just need the base and the height. Well, here, the base is going to be both these numbers together, so that's 18. That'll be the base. The height they gave you here is 16. Remember, the height and the base should always be perpendicular to one another. So on there, you're just putting those two into your formula. Area equals base times height. Plug in the 16 and the 18. 16 times 18, I believe if I remember correctly, was 288. Now, the units were in feet. So since the units are in feet here, our answer should end up being in feet squared. All area answers should be in units squared because it's a two-dimensional measurement. On number two. Number two is a little more challenging. There is 24 given to us on one side. They tell us that all the sides are congruent, so we can say that this side is also 24. But that's not my height. I need to figure out what my height is. So if I know that this is 24, and this is 24, and this piece is 60, there has to be enough information here to solve. The key is this angle is 60. If that angle is 60, the angle across from it's also going to be 60. That's one of our properties of a parallelogram. They have this height drawn in, and they have it drawn in that particular spot because now this is a 30, 60, 90 triangle. So we can use special properties of a 30, 60, 90 triangle in order to solve it. So in a 30, 60, 90 triangle, the 24 is on the side that would be my hypotenuse. The hypotenuse is double the short leg. So the short leg of this would be 12. If I know the short leg, then the long leg is the short leg times square root of 2. So 12, sorry, not square root of 2, square root of 3. So the height here, in this case, is 12 square root of 3. There are going to be properties that come back from earlier sections. I told you when we did the section on right triangles and trig that we'd see a lot of it coming up. When we do these shapes, whether it's two-dimensional shapes or three-dimensional shapes, we're going to be using a lot of those ideas again, whether it's Pythagorean theorem, special right triangles, trig. A lot of those ideas do come back. Pythagorean triples, also something that we could use. So we have a height, we have a base, plug it in. Area equals 24 times 12 radical 3. 12 24 gives us 288. That's an exact value. Now, this one did say round. So if we were to multiply that out, 288 times the square root of 3, that is 498.8. This is in inches, so inches squared. Questions on that first page? Moving on. So on this part now we're looking at a triangle. For our triangles, again, the formula is 1/2 base times height. Most of these, they give us enough information to where we don't have to do a whole lot of extra work. However, there are some where we have to do something extra. Like number one. On number one, again, the shaded area is what we're trying to find. They gave us these two lengths over here of 3 and 5 for a reason though. We don't know our height. But if this is 3 and this is 5, what's our missing length on that right triangle? So this little triangle here. Little triangle here is a 3, 4, 5. Since inside is 4, and that 4 is our height. So plugging into our formula, where it equals 1/2 base times height. We have 1/2. Base is 15. Height is 4. Now, does it matter the order that you multiply these in? No. So a lot of times, if I have an odd number and even number, I'll always multiply the even number by the 1/2 first. So this would be 1/2 of 4 is 2. 2 times 15 is 30. Again, this is area, so I want to put my units squared. Most of these, though, do give you both parts that you need already. So like on number 2, they have everything labeled. You just have to know which parts you need. The 22 is our base. The 14 would be our height. So you have both parts you need. You just plug into your formula. Here equals 1/2 base times height. So you get 11 times 14, which is 154. 4, and this would be feet squared. Say it. Because it was 1/2 base times height, right? So I had to take the 1/2, I multiply that by one of those values, no matter which one. Right? Or if you want to multiply 22 times 14 first, you could do that and then take a half. It doesn't matter which one you do first. Yeah, it's just order operations. And really, community property allows you to multiply those in any order you want to. So, once you multiply first. All right. Those are the 2 examples for the triangles. Let's go to the next side there. On this one, now we're dealing with our area of a trapezoid. Now, I said this yesterday. The formula that they do in this book and in our other green book, they list the H value first. I don't like doing it that way, just because I don't think it makes sense. Because the formula is averaging the bases times the height. So when I write this, I'll always put the H at the end. But other than that, it's the same thing. So for the exercises, they give us everything we need on number 1. Now, does it matter what you call base 1 and base 2? No. But our bases are the ones that are parallel. The height is the perpendicular distance between the bases. They gave us all 3 parts we need. Plug it into our formula. Area equals 1/2 base 1. I'm going to call that 32. Base 2, I'm going to call it 18. And the height is 16. So 32 and 18. That gives me 50. Again, it doesn't matter what order you multiply those in. So I could say 1/2 of 50, which is 25, and 25 times 16, or 1/2 of 16, which is 8, and 8 times 50. Either way, you get 400. And this would be feet squared. Now, just because you say base does not mean that it's necessarily on bottom. So like at number 2, you have 2 bases, neither one's on bottom. You could call this base 1, you could call this one base 2. because those are the two that are parallel. The one going this way, the perpendicular distance between them, so that's our height. Again, you're just plugging in. Here equals 1/2. 12 plus 24 times 28. 12 plus 24 is 36. So you got 1/2 36 times 28. So that's then 18 times 28, which is 504 yards. So this is yards squared. Questions in that section. All right, moving on. All right. On this page, you're doing non-rising heights. So again, using that area formula 1/2 diagonal 1 times diagonal 2. Down here on the exercises. Again, some of them give you the entire length there, some of them give you them separate out. Here we have 20 and 20, so this entire line all the way across is going to be 40 units, right? Then we have going the other way, all the way across for this diagonal, 56 and 26 is a total of 82. So when we plug these in, we have area equals 1/2 diagonal 1, diagonal 2. It doesn't matter which one you call which. Like that. Doesn't matter the order that you multiply them in either. I probably do 1/2 of 40, and that gives me 20, and then that's easier to multiply by 82. So that's 164. All my original values were in inches, so this is inches squared. On number 2, they don't give us the other parts, but they have a congruency marks on there. So we have 10 for the one piece, so the other piece must also be 10. This is 20, so the other piece must be 20. So again, plug them in, area equals 1/2. If I add those together, that's 20. If I add those two together, that's 40. So 1/2 of 20 is 10. 10 times 40 is 400 centimeters squared. There's a couple on here that require algebra, so you're going to plug into the equation and solve the missing piece. On number 7, they give us the area is 164. The formula here again is 1/2 base 1 plus base 2 times height. X is our height. Those other two values were our two bases. We had the area. We plugged all those parts into our original equation. Now we have to solve for X. So first thing I could do, go ahead and get rid of the 1/2 that's being multiplied to everything by multiplying by 2. So multiply by 2, you get 328 equals, here, these two in the middle, we add those together, we got 32.8. Divide off 32.8 and you get 10 is equal to X. Okay. This really is just plugging into equations and solving or simplifying based on the question. So what I'm having you do as an assignment, I want you to do the evens only for your assignment. But again, all 4 of those pages, but evens only. All right. Question. And I'll make a spot for it on Canvas right now so that you have a spot to turn it. You have quite a bit of time in class to work on this, so again, you can use this time. That we might not have any homework tonight, you can get it all done in class time and get submitted. All right. Yes. Same on the whole thing. So on, you have pages 5, 6, 13, and 14. I want you to do them on all 4 of those pages. So